certain jurisdictions, electrical codes mandate the bonding of metallic piping systems to the electrical grounding system. This requirement extends to PVC pipes when they form a component of the water supply system. The rationale behind bonding PVC pipes lies in establishing a continuous pathway for electrical current to flow from the electrical system to the grounding electrode system. This continuity is crucial for mitigating the risk of electrical shocks and fires. To achieve effective bonding of PVC pipes, a grounding clamp and a length of ground wire are employed. The clamp is securely affixed to the PVC pipe, and the ground wire connects the clamp to the electrical grounding system. Consider the example where an electrician was instructed to bond a PVC water pipe at its entry point into the basement. The implementation involved inserting a 2-foot length of copper pipe into the PVC pipe, fastening a grounding clamp to the copper pipe, and subsequently connecting a ground wire from the clamp to the electrical panel. It is imperative to recognize that bonding PVC pipes is not universally mandated. Scenarios may arise where the water supply system is isolated from the electrical system, thereby rendering bonding unnecessary. Nonetheless, it is advisable to seek guidance from a qualified electrician to ascertain whether bonding is requisite in a given scenario. Bonding PVC pipes for grounding constitutes a safety measure that aids in preventing electrical shocks and fires. Some electrical codes stipulate the bonding of metallic piping systems, encompassing PVC pipes if integrated within the water supply system. Grounding ensures a safe path for stray electrical current. Bonding connects metallic parts to create electrical continuity. The goal is to minimize voltage differences and prevent shocks. Common grounding points include the main panel, metal water pipes, and ground rods. Proper grounding protects people and equipment from electrical hazards. Bonding minimizes the risk of electrical shock from metal parts. It also provides a low impedance path for fault current. This helps circuit breakers trip quickly. Effective grounding and bonding are crucial for electrical safety. Always follow local codes and consult with a qualified electrician. Grounding electrodes provide a connection to the earth. Common types include ground rods, metal water pipes, and concrete encased electrodes. The grounding electrode system should have a low resistance to earth. This helps to dissipate fault current. Grounding conductors connect the equipment grounding system to the grounding electrode system. They must be sized appropriately for the circuit. Bonding jumpers connect different metal parts together. This ensures electrical continuity and minimizes voltage differences. Proper installation of grounding and bonding is essential. Incorrect wiring can create dangerous situations. Always follow the electrical code and consult with a qualified electrician. Regular inspections of grounding and bonding systems are recommended. This helps to identify any potential problems. Damaged or corroded components should be replaced promptly. Grounding and bonding are critical for electrical safety. They protect people and equipment from electrical hazards. Always follow local codes and consult with a qualified electrician. Grounding and bonding work together to protect against electrical shock. Grounding provides a path for fault current to flow back to the source. Bonding ensures that all metal parts are at the same potential. This prevents voltage differences that could cause a shock. The National Electrical Code (NEC) provides detailed requirements for grounding and bonding. It is important to follow these requirements to ensure electrical safety. A qualified electrician can help you understand and comply with the NEC requirements. Grounding and bonding are essential for all electrical systems. This includes residential, commercial, and industrial installations. Proper grounding and bonding can save lives. Always take electrical safety seriously. Consult with a qualified electrician for any questions or concerns. Grounding and bonding are not the same thing. Grounding provides a path for fault current to flow to earth. Bonding connects metal parts together to equalize their potential. Both grounding and bonding are necessary for electrical safety. The grounding electrode system is the primary connection to earth. It typically consists of ground rods, metal water pipes, or concrete encased electrodes. The equipment grounding system connects metal parts to the grounding electrode system. This provides a path for fault current to flow back to the source. Bonding jumpers connect different metal parts together. This ensures that they are at the same potential. Proper grounding and bonding are essential for electrical safety. They protect people and equipment from electrical hazards. Always follow local codes and consult with a qualified electrician. Grounding and bonding are critical for preventing electrical shock. They also help to protect against fire hazards. A properly grounded and bonded electrical system is a safe electrical system. Always take electrical safety seriously. Consult with a qualified electrician for any questions or concerns. Grounding and bonding are often overlooked, but they are essential for electrical safety. Make sure your electrical system is properly grounded and bonded. It could save your life. Grounding and bonding are complex topics. If you are not sure how to properly ground and bond your electrical system, consult with a qualified electrician. They can help you ensure that your system is safe. Electrical safety is everyone's responsibility. Take the time to learn about grounding and bonding. It could save your life or the life of someone you know. Bonding is the permanent joining of metallic parts to form an electrically conductive path that will ensure electrical continuity and the capacity to conduct safely any current likely to be imposed. This creates a low impedance path for fault current, facilitating the operation of overcurrent protection devices like circuit breakers. Grounding is connecting to the earth with some conducting body that serves in place of the earth. It provides a reference point for voltage and a path for fault current to return to the source, tripping the overcurrent protection. The NEC specifies requirements for grounding and bonding to minimize electrical hazards. Section 250.45 emphasizes that electrical equipment should be installed in a manner that creates a low impedance ground fault current path, facilitating the operation of overcurrent devices. Section 250.92 covers bonding of metal water piping, requiring it to be bonded to the service equipment enclosure, the grounded conductor at the service, the grounding electrode conductor, or one or more grounding electrodes used. Section 250.104 provides further details on bonding metal water piping systems. It's important to note that while metal water piping often serves as a grounding electrode, plastic piping necessitates alternative grounding methods. The main bonding jumper is a conductor that connects the grounded circuit conductor neutral to the equipment grounding conductor at the service equipment. Its size is determined by NEC Table 250.102 cone. Equipment grounding conductors EGC are used to connect non-current carrying metal parts of equipment to the grounding system. Their size is determined by NEC Table 250.122, based on the rating of the overcurrent protective device protecting the circuit. Grounding electrode conductors connect the grounding electrode to the service equipment or separately derived system. Their size is determined by NEC Table 250.66 based on the size of the service entrance conductors. Ground rod should be at least 8 feet long and driven at least 8 feet into the earth. 2 ground rods are generally required, spaced at least 6 feet apart. The resistance of the grounding electrode system should not exceed 25 ohms. If it does, an additional grounding electrode is required. Bonding bushings and bonding jumpers are used to bond metal enclosures and raceways. They ensure electrical continuity and provide a low impedance path for fault current. Listed grounding and bonding equipment should be installed according to the manufacturer's instructions. Proper grounding and bonding are essential for electrical safety, protecting against electrical shock and fire hazards. Firstly, ensure all metallic parts are properly bonded together. Secondly, use appropriately sized grounding and bonding conductors. Thirdly, follow all applicable NEC requirements. A qualified electrician should perform all grounding and bonding work. They have the knowledge and experience to ensure that the work is done safely and correctly. Regular inspections of grounding and bonding systems are important to identify any potential problems. Damaged or corroded components should be replaced promptly. Grounding and bonding are not a one-time fix. They require ongoing maintenance to ensure that they continue to provide adequate protection. Grounding and bonding are critical components of electrical safety. They protect people and equipment from electrical hazards. Always take electrical safety seriously. Consult with a qualified electrician for any questions or concerns. Grounding and bonding are often misunderstood, but they are essential for electrical safety. Take the time to learn about them. It could save your life. In the described scenario, the inspector's requirement to bond the PVC pipe raises questions because PVC is a non-conductive material. The purpose of bonding is to create a low impedance path for fault current in metallic piping systems. If the entire water supply system is PVC, there is no conductive path to bond. However, the presence of a 2-foot copper pipe insert changes the situation. The inspector likely required the copper pipe to be bonded to the electrical grounding system, effectively using the copper as a grounding electrode. The copper pipe would need to be connected to the electrical panel's grounding bus by using a grounding conductor of appropriate size, based on the electrical service size. The connection should be made using listed grounding clamps suitable for copper pipe. This setup aims to provide a path for fault current if the copper pipe becomes energized. Without the copper insert, bonding the PVC pipe itself would be ineffective.